Electric propulsion, producing an astonishing 800 horsepower and 1,250 Nm, or 922 pound-foot of torque, while weighing just 86 pounds, this was not just a leap forward, it was a revolution in engineering. This compact, pizza-sized motor sent shock waves through the industry. For years, Tesla, under the leadership of Elon Musk, had dominated the electric vehicle (EV) landscape, convincing investors, enthusiasts, and competitors alike that massive battery packs and over-the-air software updates were the future of mobility. Tesla's strategy was clear: scale production, refine battery technology, and stay ahead by evolving software features like full self-driving (FSD). Yet, Koenigsegg's innovation challenged that narrative. It raised new questions about Tesla's grip on EV dominance and sparked a broader conversation about the future of automotive propulsion. The reveal of the dark matter motor wasn't just a typical product launch, it was a bold statement. Broadcasted live from Koenigsegg's sleek, state-of-the-art facility in Ängelholm, Sweden, the event captivated automotive journalists, engineers, investors, and industry insiders worldwide. Christian von Koenigsegg, the company's visionary founder and CEO, stood before a global audience and declared with characteristic conviction, "We didn't set out to slightly improve what's already out there. Our goal was to reinvent the electric motor entirely." His words were not hyperbole. The dark matter motor, with its unprecedented power-to-weight ratio, shattered conventional assumptions about EV design and efficiency. For the first time in years, Tesla's once seemingly insurmountable technological lead appeared vulnerable. The ripple effects were immediate and widespread. Social media platforms like X, formerly Twitter, buzzed with excitement, as automotive enthusiasts and tech experts shared posts highlighting the motor's jaw-dropping specifications. 800 horsepower from a 39 kilograms 86 pounds unit, many wrote, a feat that dwarfs the power density of Tesla's motors. Analysts and market experts began speculating about the implications for the broader EV market. While die-hard Tesla fans debated whether this was the start of a new era in automotive engineering, somewhere in Austin, Texas, Elon Musk himself was watching, and the pressure was mounting. At the heart of Koenigsegg's breakthrough is the dark matter motor's innovative radial flux design, a hybrid of radial and axial flux motor architectures. Traditional radial flux motors, used in most EVs including Tesla's flagship Model S Plaid, feature a rotor with magnetic flux lines pointing outward from the axle, spinning at high RPMs within a cylindrical housing. This design is efficient, but it comes with trade-offs between torque and power density. Axial flux motors, by contrast, have a larger diameter and a pancake-like shape, with magnetic forces running parallel to the axle. These designs typically produce higher torque at lower RPMs, but are bulkier and harder to integrate into compact powertrains. Koenigsegg's radial flux approach cleverly combines the best of both worlds, delivering exceptional power density in a compact, lightweight package that stunned even seasoned engineers. What truly sets the dark matter apart is its revolutionary construction. While Tesla and other EV manufacturers have long relied on laminated steel plates to amplify magnetic flux in their rotors and stators, Koenigsegg made a bold leap by using carbon fiber for the rotor, stator, and housing. This world-first approach in production EV motors significantly reduces weight without compromising structural integrity or thermal performance. Traditional wisdom held that steel was essential for amplifying magnetic fields, but Koenigsegg's engineers reimagined the motor's functionality with a groundbreaking 6-phase winding system. Unlike the standard 3-phase motors that dominate the industry, the 6-phase configuration distributes magnetic loads more efficiently, reduces thermal stress, and enables smoother, more responsive power delivery. The result is a motor that not only matches but surpasses the performance of conventional designs by a substantial margin. At just 15 inches in diameter and 5.3 inches thick, the dark matter motor produces an astonishing 600 kilowatts, 805 brake horsepower, and 1,250 Nm of torque, with a peak rotational speed of 8,500 RPM. For comparison, a single Tesla Model S Plaid motor generates roughly half the horsepower and weighs slightly less than the dark matter. However, Tesla's flagship Model S Plaid requires 3 motors to achieve its mind-bending performance numbers. Koenigsegg's motor achieves equal or greater output with a single unit, redefining what's possible in the realm of EV propulsion. Complementing the motor is Koenigsegg's silicon carbide inverter, aptly dubbed David. Weighing just 33 pounds, David delivers 1,300 amps at 850 volts, enabling the dark matter motor to operate at peak performance with minimal heat loss. The use of silicon carbide semiconductors, known for faster switching speeds and lower resistance compared to traditional silicon components, further enhances efficiency and energy conversion. When Christian von Koenigsegg was filmed casually holding the entire motor and inverter system, lighter than most carry-on luggage, the contrast with Tesla's heavier, steel-based designs was unmistakable and symbolic of a shift in EV innovation. For over a decade, Tesla's dominance in the EV market has rested on two primary pillars: cutting-edge battery technology and a carefully cultivated perception of technological invincibility. Tesla's gigafactories churn out vehicles at scale, supported by a robust global charging infrastructure and software-driven features like autopilot and FSD. In 2024, Tesla generated a staggering $77 billion in automotive revenue, bolstered by $2.76 billion from regulatory carbon credits. Elon Musk's charisma and audacious promises, electric cars, humanoid robots, even Mars colonization, have kept Tesla at the forefront of both investor enthusiasm and consumer loyalty. But Koenigsegg's dark matter motor challenges Tesla's core assumptions. By achieving unprecedented power density, this motor reduces the need for massive battery packs, which have long been a necessary but cumbersome trade-off between range and vehicle weight. Suddenly, the tug-of-war between performance and efficiency seems far less inevitable. A lighter, more powerful motor opens up exciting possibilities for vehicle design, from compact performance cars to spacious family sedans that still deliver sports car-like acceleration. Koenigsegg's boutique approach, building fewer than 70 Gemera hypercars annually, allows its engineers to push boundaries without the constraints of mass production that Tesla faces. Christian von Koenigsegg often emphasizes this philosophy. We don't outsource innovation. If the part we need doesn't exist, we invent it, he famously stated during the launch event. This hands-on approach has enabled breakthroughs that larger automakers, bogged down by complex supply chains and rigid production schedules, have struggled to match. While Tesla has refined its steel-based motors and focused heavily on economies of scale, Koenigsegg has leapt ahead by reimagining both the architecture and the materials at the very core of electric propulsion. Imagine a scenario where, just days after Koenigsegg's groundbreaking reveal, Elon Musk appears on a major financial news network to discuss Tesla's latest quarterly results. The interview, intended to be a triumphant victory lap celebrating Tesla's growth and performance, takes an unexpected turn when the host pivots the conversation to Koenigsegg's dark matter motor. Many are calling it a game-changer for electric propulsion, the host remarks, citing the motor's 800 horsepower and 86-pound weight. Musk, known for his quick wit, sharp retorts, and unshakable confidence, pauses, an unusual and telling moment of hesitation. For 3 seconds, the camera captures a subtle but unmistakable shift in his demeanor. His eyes widen slightly, his mouth twitches as if searching for the right words, and his posture stiffens. When Musk finally responds, his tone is measured, but noticeably lacks its usual bravado. Koenigsegg has created something interesting, Musk admits, choosing his words carefully. But we'll need to see how it scales. The host, sensing an opening, presses further, asking whether the dark matter motor's specs might force Tesla to rethink its approach to electric propulsion. Musk's expression darkens ever so slightly. He leans forward and asserts, Tesla revolutionized this industry, before listing the company's achievements, building the first viable mass-market EVs, creating a global charging network, and pioneering over-the-air updates that have redefined automotive software. Yet, the moment feels different this time. The flicker of vulnerability in Musk's expression suggests that Koenigsegg's breakthrough has struck a nerve, challenging Tesla's narrative of being untouchable. This scene, while hypothetical, underscores the stakes at play. Tesla's brand is built on being the technological frontrunner, and any challenge to that narrative, especially one as dramatic and disruptive as the dark matter motor, has the potential to unsettle investors and shake consumer confidence. Social media platforms like X reflect this sentiment. Posts and trending hashtags showcase users marveling at Koenigsegg's innovation, with many questioning whether it could disrupt Tesla's dominance in ways no competitor has yet managed. Some users even speculate, half-jokingly, that Musk might have been blindsided by the reveal, though no evidence suggests that Musk resigned or showed emotional distress on live TV. Nonetheless, the idea captures the potential industry-wide impact of Koenigsegg's leap forward. Koenigsegg did not stop at the dark matter motor. At a private event attended by select journalists and industry insiders, Christian von Koenigsegg unveiled his company's broader vision, a complete reimagining of propulsion for high-performance vehicles. The motor, he explained, is merely the centerpiece of the Gemera, JRA, Koenigsegg's upcoming 4-seat hybrid hypercar, which is set to begin deliveries in early 2025. The Gemera represents the culmination of years of engineering excellence, blending cutting-edge electric technology with the raw power of internal combustion. When paired with a 5.0-liter twin-turbo V8 and an all-new tourbillon drive system, the dark matter motor enables the GEM ERA to produce a combined 2,300 horsepower, a figure that far surpasses Tesla's Model S Plaid, which maxes out at approximately 1,020 horsepower. The tourbillon drive system is a technical marvel in its own right. It integrates the electric motor just ahead of the mid-mounted V8 engine, connected via a specialized clutch that allows seamless switching between electric-only, combustion-only, or hybrid power modes. This level of flexibility is something Tesla's battery-only approach cannot match. By offering the best of both worlds, instant electric torque and the visceral thrill of a combustion engine, Koenigsegg is signaling that the future of high-performance vehicles may not be purely electric, but rather hybridized for optimal performance and efficiency. This flexibility challenges Tesla's long-standing bet on all-electric powertrains, suggesting that high-performance hybrids could deliver superior power and range without the weight penalties associated with large battery packs. Equally groundbreaking is Koenigsegg's revolutionary dielectric cooling system for the GEM ERA's battery pack. Unlike traditional EV cooling systems, which rely on plates or tubes that pass coolant around the cells, this system floods the battery pack with a specially formulated, non-conductive oil. This oil, blended with proprietary additives, ensures direct contact with every battery cell, enabling superior heat dissipation. The benefits are profound. The battery can operate at higher loads for longer periods, stay cooler, and weigh significantly less. By solving one of the most persistent challenges in EV design, thermal management, Koenigsegg is positioning the GEM ERA not just as a hypercar, but as a platform for next-generation EV technologies. The implications of the dark matter motor and its associated technologies extend far beyond hypercars. While it debuts in the ultra-exclusive $2.60 to $6 million GEM ERA, the innovations behind it are likely to trickle down to mainstream vehicles over the next decade. The compact size, lightweight nature, and high efficiency of axial flux motors open up new possibilities for a range of vehicle types, from lightweight sports cars to electric motorcycles and even compact performance vehicles like the Ariel Atom. Analysts suggest that as manufacturing costs decrease and scalability improves, this technology could eventually find its way into sedans, SUVs, and commercial EVs, reshaping the landscape of electric mobility. For Tesla, the challenge is now twofold. First, the dark matter motor highlights the limitations of its steel-based motor designs, which are heavier and less power-dense by comparison. Tesla's approach,